Alright, I guess I'm back for some more of this shit. Let's fucking go. Alright, so now I'm at section 3-4. Fucking factorials and permutations. Factorials and permutations. Right? So, yeah. Let's see what it says here, okay? In working examples from the previous two sections, you may have noticed that we often need to count the number of non-repetitive lists of length n that are made from n symbols. This kind of problem occurs so often that a special idea called a factorial is used to handle it. The table below motivates this. The first column lists a successive integer values n from O onward. The second contains a set AB of n symbols, whatever. Third column shows all the possible non-repetitive lists of length n that can be made from these symbols. Finally, the last column tallies up how many lists there are of that type. When n equals 0, there is only one list of length 0 that can be made from 0 symbols, namely the empty list. Thus, the value 1 is entered in the last column of the row. Alright, so what the fuck are they even talking about? Let's try to write this up. Alright, so get the fuck away from this. And we got n, right? Symbols. Non-repetitive lists of length n made from the symbols. Alright, so non-repetitive lists of length n made from the symbols. I'm so sorry about this, but you know, it's all good. And then the factorial. I mean, what the fuck are we doing here? What the fuck am I even doing? So this is basically, you know, they're just showing you like, alright, so if you got one, what is it, set? I mean, it is a set, right? The symbols? Yeah. So, you know, if you got one set, I'm not even going to use this. If you got one empty set, that's going to give you like an empty list. So, basically 0 factorial is going to be 1. That's all they're saying. And then, you know, if you have one element in this list, you know, it's also going to be 1. Believe it or not. Yeah, so, and then if you got, you know, if you got 3 elements, it's 3 factorial. You can make 6 different kinds of lists. Alright, so I'm getting this. No problem. I don't even need to write the shit up, actually. Alright, for n greater than 0, the number that appears in the last column can be computed using the multiplication principle. The number of non-repetitive lists of length n that can be made from n symbols is n times n minus 1 times n minus 2, so on, you know. They're basically just explaining factorial, you know. But we're not, this is fine. If n is a non-negative integer, then n factorial is the number of lists of length n that can be made from n symbols without repetition. Alright, so whatever. Here it says, students are often tempted to say that 0 factorial equals 0. But this is wrong. The correct value is 1. So, it's actually 1. Wait, I can't do that. Alright. Good. It's probably something I should go into here, because, I mean, does that make sense? How does that make sense? All right, we see that we can generalize and we can say that n factorial is basically, is this like some kind of recursive shit? All right, makes kind of sense, right? So if we plug in n equals 1, that gives 1 factorial. That gives us 1 factorial equals to 1 times 1 minus 1 factorial, right? So that's going to be 1 factorial, 1 times 0 factorial. Yeah, alright. Now, if we say that 0 factorial is 0, then that would make sense. But it kind of feels like we're just like saying, no, it has to be 1. I don't see like a real reason behind this being. How do you even. I mean, it's nice. If 0 factorial is 1, it fits, right? But you know, we're not. Are we proving it? I don't feel like this is like a. I feel like we're kind of like. It would be nice if this was true, kind of in a way, you know. All right. Well, fuck it. I'm not gonna. For now, I think it's fine to just say that. All right, 0 factorial is 1. Right? So, what happens if we go ahead and plug in 0 here, though? Like, if we would say 0 factorial equals 0 times 0 minus 1 factorial, this is just going to be. And then anything multiplied by 0 is just going to be 0. So, what the fuck are we talking about here? How is this gonna be 1? I can just as easily say this. The fuck? This doesn't make. I don't know. This is not good enough. Maybe I need to investigate this. Why is 0 factorial actually 1? I mean, I understand that it's nice if it is. What does it have to be, though? I don't see it. I don't see it. But alright, whatever. Because, I mean, over here, check it out. What the fuck? I could just, like, couldn't I argue this? Yeah, that's crazy, actually. What the fuck? If n is a non-negative integer, maybe that's what it is. You know, like there's something baked in this bullshit right here. So maybe this formula doesn't work this way. You know, unless we have. Yeah. All right, fuck it. You know what? Right, we're just gonna say 0 factorial. This is not real sciencey of me, but we're gonna say this. We accept this, and I'm gonna try to maybe later figure out why it has to be this way. I get that it's nice, all right, but I'm just saying, what the fuck? All right. No, because what the fuck? No, seriously. What the fuck? How can this be? Wait. All right. So if we descend by 1, wait, we're approaching 0, or are we moving in the opposite direction of? So all right. So I like if I have 5 factorial, that's 5 times 4 times 3 times 2 times 1. Cool, cool, cool. 0 factorial. 0 times what, dude? I mean, I'm seeing that I have to start in 5. What is going on with this 0? Why doesn't it start? Because anything multiplied by 0 is 0. We've learned that. Is there something you can multiply 0 by to get that 0? What does it mean to multiply by 0? Yeah, that's crazy. Fuck it. Alright, so yeah, we're just gonna accept this and just gonna move on. I can't though. I can't. Why does it have to be 1? Why does it have to be 1? 1 factorial, I get is 1. Because you get like just fucking 1. You know, 1 times what? 1? Or whatever. But 0 factorial. I remember doing some probability shit. There was kind of like an explanation in there. But it was also kind of like, let's make it fit. You know? Is that allowed? You can just make a definition fit? I mean, I guess. But it seems kind of fucky. I don't know. Alright, so fuck it, whatever. We're just gonna... This problem involves making lists of length 7 from the letters A, B, C, D, E, F, and G. How many such lists are there if repetition is not allowed? I mean, there are 7, so that's 7 factorial, yes. 5040. How many such lists are there if repetition is not allowed and the first 2 entries must be vowels? Yeah. Alright, so what the fuck? How many vowels? A and E, that's the only vowels in there. So that's going to be 2 times 1. Right? So we got 7 letters. A, B, C, D, E, F, G. Now these are vowels, so the first one got to be one of those. It's got to be 2 times 1. These are my vowels that we start with. And then times the rest, 7 minus the 2 vowels that I used. Wait, the others can't be vowels? Oh yeah, the 5... Yeah, the rest of them have to be consonants. So yeah, this is going to be that. Yeah, we get 240. Alright, cool. Whatever. Alright, what the fuck are they getting at? How many such lists are there in which repetition is allowed, and the list must contain at least 1 repeated letter? Yeah, that's... alright. Subtraction principle. Let the set U... The fuck? Let the set U... This is a set. Alright, so U... Lists... Like the set of all lists. Yeah, that's what I did earlier. Yeah. So that's gonna be like... everything's loud, fuck it. So like the cardinality, is that what they say, of this set? It's gonna be 7 to the 7th. And then that's gonna be fucking... yeah. It doesn't matter, does it? But, well, let's write it down. Let's keep it real. Or whatever. So... Non-repetitive. Yeah. Some repetition. We want to find a number of lists that have at least 1 repeated letter. Alright, so... yeah, so we find a set that has no repetitions, which is going to be basically 7 factorial, right? I'm just going to be a calculator, right? Answer over there. And then we take basically this number, subtract it from this one, and then we have the list where there's some repetition, right? Or yeah. Yeah, alright, that makes sense. Let's move on. Um, yeah, whatever, whatever. All right, here we're getting into permutations, I guess, right? So, what are we doing over here? In part A of example 3.8, we counted the number of non-repetitive lists made from all 7 of the symbols in the set X. A, B, C, D, E, F, G, and there were 7 factorials, 5040 such lists. Any such lists, such as B, C, E, D, A, G, F, or whatever, is simply an arrangement of the elements of X in a row. There is a name for such an arrangement. It's called a permutation of X. Um, so this is a list where you're using all the elements of a set, and there's no repetition. Basically, that's what a permutation is. All right, cool. Um, all right, think of numbers 1 to 3 representing 3 books. The above shows that there are 6 ways to arrange them on a shelf. From a deck of cards, you take 4 queens and lay them in a row. By the multiplication principle, there are 4 factorial, 24 ways to do this. That is, there are 24 permutations of the set of 4 queen cards. Alright, cool. Yeah, permutations, whatever. What do we got? We got some classroom shit. They're saying not everything has to be in a row, literally. What does that even mean? Um, I don't, fuck it. That doesn't seem important. I do that all the time when I'm reading. Maybe that's why I have so many gaps in my knowledge. But whatever. Now we discuss a variation of the idea of a permutation of set X, of a set X. Imagine taking some number. Right, here we're getting into some good, maybe something new. Imagine we're taking some number k less than or equal the cardinality of the set of X, and then arranging them in a row. This result is what we call a k permutation of X. Alright, so a permutation of X is a non-repetitive list made from all elements of X. A k permutation of X is a non-repetitive list made from k elements of X. So you're not using all the elements. You could, but you could also choose like a subset of X, I guess, and permutate those. For example, take X, A, B, C, D, where those letters are elements. The 1 permutations of X are the list we can make with just 1 element from X. There are only 4 such lists. The 2 permutations of X, yeah, alright, so here we go. And then the 2 wait. Even before writing them all down, we know there are 12 of them, because in making a non-repetitive length 2 list from X, we have 4 choices for the first element, then 3 choices for the second. 4 times 3, really, 12. 4 times 3 times 2, that is the 3, what do you call it, 3 permutation of X. Wait a goddamn minute. Wait, so if I have X, let's say I have 4 elements in there, right? I got A, B, C, D. All good. And then, hold up. So I got like, alright, let me see. I want to do like 3 permutations of X. How do I even write that? Alright, 3P, whatever. C3PO. Star Wars. And may the Force be with you. And here we go. Alright. I'm not like a Star Wars geek or anything, but you know, it's all good. The new ones are fun. Now I might have ADHD. Why am I talking about Star Wars? Let me get back to this. All right, focus, focus. So we have this, right? 3 permutation of X. They are the length 3 non-repetitive lists made from elements of X. But why does the multiplication principle say that there will be 4 times 3 times 2 of those lists? Why? Because we're counting how many lists we can make, right? I guess it makes sense actually. Wait, so first I can, in one of these lists, I can use all of the letters, all of the elements, 4 of them, multiply that by 3, multiply that by 2, and then the last slot I'm not using because this is a 3 permutations of X. So, wait, what the, hold up. But then are you telling me that the 3 permutations of X will be the same as the full permutation of X? Because what the fuck, if I want to just permutate X, it will be this, right? Which is basically the same as this shit. Something's fucky there. Well, let me read on with it. The 4 permutations of X are the non-repetitive list made from all 4 elements of X. These are simply 4 factorial, 24, like the same as this shit, right? Yeah, all good. Now they want me to go back and think about the 0 permutations of X. They are the non-repetitive lists of length 0 made from the elements of X. Of course, there is only one such list, namely the empty list. Yeah. Once again, it fits nicely, but you know, alright, so something about the rule of permutations that doesn't quite sit well with me when they say that 0 factorial is 1. I get it, but I mean, what the fuck is going on over here? Like I don't know, but alright. Witchcraft, you know. Something, well, whatever. Yeah, alright. Now they want to introduce some notation. I'm not really getting the answer of why would, I guess kind of it makes sense because, you know, you've already, like, used up, like, the only possibility left. If I add an additional slot, it doesn't really change it, does it? Because there's only one letter left, and they have to be non-repetitive. So it doesn't really change the, like, it's just, like, added on. Whatever. Alright, fuck it. I'm happy with that one. Then they have some new notation. We got the expression P, N choose K. I think I've seen this before. And then, so, denotes the number of K permutations of an N element set. So let's say we got, they write some shit here. Let's break it down. We got 4, 0. That's going to be 1. We got 4, 1. Now that's going to be 4, motherfucker. Right? Because we got, the set is 4, but now you're actually choosing one of the elements, and there are 4 total elements. So you get 4. Yeah. Alright. Cool. 12, 24. You just increase the K there, and 24 again. What about, oh, wait a minute. Here they come with some fucking, like a, oh shit. What about 4, 5? This is gonna break the non-repetitive shit, right? So, yeah, there's no such list. Alright, cool. So 0, yeah, because then you would have to repeat it, one of the elements, and I guess that is not cool. Alright, so we're not doing that. If n is greater than 0, then P and k can be computed with the multiplication principle in making a non-repetitive length k list. From n symbols, we have n choices for the first entry, n minus 1 for the second, etc., right? Huh. Here they're writing. All right, so they're kind of all right. So here's something I gotta chew on. We got the first. We got the second over here. Oh shit, boy! We got the third coming in. You know, and we got the. Let me just fucking fourth. My pen is kind of working again now, which is kind of cool. Self-healing pen. Then, you know, a bunch of stuff happens here. It's all good. And then the last one's going to be the kth element? Yeah, or whatever. And then n minus k plus 1 over here. That's the one I really want to get at, because this is n. I get that. N minus 1, I get that. And fucking whatever. N minus 4, all good over here. But n minus k plus 1. Yeah, so the kth entry has n minus k plus 1. Now, what I'm immediately trying to not get fucked up over here is that plus 1. What is that shit? So n minus k, we've basically used up all of the elements, but we still want to include the last element. Why haven't we... What the fuck is going on here, dude? I get, like, yeah. So if we have, like, P4, you know, the last one still has to be used, but, what is going on here? Because here we use the first one, n, you know, and then we use the second one, etc. Then we use the last one, plus 1. The fuck am I not getting here, dude? What the absolute fuck? Why? Wait, let me... P10, 10. Alright, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Why is there still 1 there? 1 there. Yeah, I mean, if we go 1 past, it's gonna be times 0, which is fine. Why do I end up with 0 here? That's what I kind of want to know. If that plus 1 wasn't there, then I would have to multiply this whole shit by 0, just simply from using all of the elements. It's probably obvious, but shut up. I'm trying my best. Alright, so I guess... Alright, let's say we have... Let's use this fifth. Alright, so we have P5. We're gonna... alright, so cool. So we got P here. We got 5. 5 minus 1, that's 4. 2 plus 2, that's 4. Minus 1, that's 3. Quick maths. So 3, 2, 1. Why am I'm ending up with 1? If I just say like that fifth one is the last one. You know? So that I basically... I have n. 1, 2, 3, 4, 5. That's n. And k is also 5. I'm cool by ending up with 1 there. 1 there. Why do I need this plus 1? The fuck am I missing? But I guess that would be the same if I just Oh, maybe this. Oh, right. So maybe like because if I had n minus k at the last one, I'm just kind of showing like maybe that because there would be 5 minus 5 plus 1. Is this like an infinity thing? You know, because I can obviously see that it's going to be. This is just like a formula, right? So at the last, whatever that last thing is, it's going to be. It's just to include. Yeah, okay, fuck it. I kind of. Yeah. I can't wait, but I should be able to explain it though. It's because we don't know what K is, but whatever K is, if you're gonna choose all of them, you're gonna do n minus K plus 1. Fuck it. Yeah, makes sense, but how do I explain it? Because what is this I'm brushing up against? What is this? What is this? Who is this? Who you is? N minus K plus 1. You're basically ensuring that there's gonna be times 1 at the end when you've used all the elements. Can I do it? Can I say n minus K plus 1 already here? So let's say I have P2. That's gonna be, 2. Then it's gonna be 2 minus 2 plus 1. I mean, yeah, fuck it. But, alright. I guess maybe I shouldn't like... But there's something there though that I would really like to... show itself to me. What is it? What is it? Fuck it. I don't know. I mean, yeah, I get it. Well, I don't... If I could get it, I could explain it simply, right? That's an Einstein thing. Or not, it's not his thing, but I mean, maybe he said it. I don't know. Alright, so... Fifth position. It's just because you don't know how far you go. Or you can write the same for any of these. That's maybe what's tripping me up, because you could just say n minus k plus 1. You could do that the entire fucking way. So why are they choosing to say n minus 1, then n minus 2, you know? Maybe they're just showing you like say that the list is gonna be long, then you can assume that if you're going to the end of the list, you can just, you know, do it here. But really, maybe they should just say n minus k plus 1 everywhere, actually. And then let you choose how far you want to go. Is this to show scope, dude? Or what the fuck? Alright, fuck it. Maybe I'm getting hung up on this for no fucking reason, but... Anyway, alright, so it's all good. And then, you know, if you go past the available amount of elements, you choose k greater than n, then yeah, this is gonna end up being 0. It's all cool. Okay. Now, yeah. Yeah, whenever k is greater than, n is gonna be 0. Notice that the permutations of choosing all the elements in a set is just gonna be that n factorial. Yeah. I guess. We now derive another formula. And we derive a formula, my boy. P n k, right? Which is gonna be basically what the fuck is this? Wait, where was I? One that works for 0 greater, k greater or equal to 0, less than or equal to n. Cool. Using equation whatever, we get this. Alright, so what they kind of are spitting at me is this shit right here. n minus k factorial. So what the fuck is this, dude? Oh wait, this is basically like, all right, so you have the total number, you know, whichever last, like however far you go, you just remove those, yeah, because those are gonna get canceled, and then you, yeah, I kind of see it, yeah, all right, so whatever, but that is only here, I guess, right? In between, if k is between here, yeah. But then wait a minute. Oh yeah, because if k is n, it's gonna be 0 factorial at the bottom, which is gonna be 1. I mean, it's unsatisfying to assume that it is 1, but it works, so it's cool. I mean, it's just a definition, right? Or am I fucking tripping? Whatever, dude. Yeah, and then if you choose 0 elements, it's gonna be n factorial over n factorial, which is 1. And then what if you choose 0, 0? That's going to be 1 over 1. But, oh fuck, why is 0 factorial 1? Alright, fuck it. I'm not going to... I mean, I'm sure if there was a simple explanation for it, they would have said it, but... I mean, they're wizards. I'm just like a peasant trying to play with symbols over here. So they probably know what they're doing. But I want to know what I'm doing too, so I'm gonna, I swear to God, it's gonna make sense one day. But, you know. Let's see. Alright, we got more examples, we got more shit, and then there's exercise time. So, 10 contestants run a marathon. Cool. All finish, and there are no ties. How many different possible rankings are there for first, second, and third place? Alright, cool. I mean, that's gonna be... I mean, that's kind of fucking whatever. It's gonna be this. That's exactly what it says. 720. No big deal. You deal 5 cards of a standard 52 card deck and line them up in a row. How many such lineups are there that either consist of all red cards or all clubs? So here they do some shit. Addition principle. Yeah, this is fucking all good. Alright, the next is exercise